Hello friends, greetings from Professor M.I. Vyas. I am Associate Professor, Government Engineering College, Modasa. We have already started the learning about heat engine. We have seen in our heat engine in the previous 4 lectures what is heat engine. Then we have seen the classifications of the heat engine. We have seen the cycle, the Carnot cycle, gas as well as vapor as a medium. Limitation of the Carnot engine. Based on these limitations, or this limitation leads us to think over the engine which works practically. So the practical engine, what kind of the engine is required, that we have seen. And this practical engine which work on Rankine cycle, Otto cycle and diesel cycle. We have also done some exercise on Rankine cycle as well as Otto cycle. Last time we have already learned the diesel cycle, the theory part, analysis of the cycle. This time we will do some exercise on the diesel cycle as well as some other cycles. Determine the efficiency of the oil engine which is working on a diesel engine with the temperature of 27 degrees centigrade at the starting of the compression. The ratio of compression and adiabatic expansion is 18 and 9 respectively. Take gamma is equal to 1.4. Here we have to determine the efficiency of an engine which is working on a diesel cycle. 2 ratios are given, compression ratios and expansion ratios. Let us try to understand the data what is given by studying this figure. Diesel cycle. So we have drawn the figure. You can say the property diagram, PV diagram for the diesel cycle. In other words, we have drawn the diesel cycle on a PV diagram. Process starts from point 1, it goes to point 2, that is the compression, and for that compression ratio is given 18. Process 2 to 3 heat addition at a constant pressure, and process 3 to 4, that is expansion, and 4 to 1 heat rejections. Compression ratio is given 18, that is seen in the figure. R is equal to 18. Cutoff ratio is also given that, and based on this you have to find out the expansion ratio. You can see the ratio of compression and expansion is given 18 and 19 respectively. With this compression and expansion ratio, you have to find out the efficiency of the cycle. Let us see that how we can find out the efficiency of the cycle. What is given? Compression ratio is given, that is equal to R is equal to V1 upon V2, that gives, it is 18. Expansion ratio, that is equal to V4 upon V3, it is equal to V1 upon V3 is equal to 9. This is given. So therefore cutoff ratio is equal to RC is equal to V3 upon V2 is equal to V1 upon V2 upon V1 upon V3. So V1 upon V2 is 18. V1 upon V3 is given 9. So it is 2. Cutoff ratio RC is 2. Based on this, you can find out the efficiency of the cycle. You can see in this slide, compression ratio is 18. Now cutoff ratio that we have find out is 2. Initially it is given 300 Kelvin, this is 27 degree. It is so you can very well understand how this compression ratio and expansion ratio is given, that based on that cutoff ratio we have find out. You can see the diagram of the diesel cycle on PV plan. You can see that efficiency of the cycle is equal to 1 minus 1 upon R raised to gamma minus 1 into 1 upon gamma into RC raised to gamma minus 1 upon RC minus 1. Put the values. 1 upon 18 raised to 1.4 minus 1 multiplied by 1 upon 1.4 into cutoff ratio is how much? 2. 2 raised to 1.4 minus 1 upon 2 minus 1. Calculation of this gives you 0.6316 is equal to 63.16% is the efficiency. Is the efficiency of the cycle. Efficiency 0.6316, that is 63.16% efficiency. This is your answer. So look at this slide. It is given that compression ratio is 18. Expansion ratio is given 9. Based on that cutoff ratio we got 2. The cycle we have drawn for understanding how the process goes on. By using the cycle efficiency equations, we have find out that the efficiency of the engine is 63.16%. We move further. In an ideal diesel cycle, the temperature at the beginning and at the end of compression are 57 degrees centigrade and 603 degrees centigrade respectively. The temperature at the beginning and at the end of expansion are 1950 degree centigrade and 870 degree centigrade respectively. Determine the efficiency of the cycle. If the pressure at the beginning of the cycle is 1 bar, calculate the maximum pressure in the cycle. Calculate the maximum pressure in the cycle. See what is given. If we refer the now all of you are knowing the diagram of diesel cycle, the previous numerical problem which we have solved. You refer the figure. It is given the beginning of the temperature 57 plus 273, it is 330 K. T2 is given 603 degree centigrade plus 273, it is 876 Kelvin. T3 is given 1950 plus 273, it is 2223 Kelvin, and T4 it is 870 is given, sorry, 870 plus 273 1143 Kelvin. These are the given. Pressure is also given. P1 is 1 bar. Determine the efficiency of the cycle. Ideal efficiency is how much, and the maximum pressure, and the maximum pressure. This is given, and we have to find out efficiency and the maximum pressure. So here if not given, in that case for air you take gamma is equal to 1.4. So by fundamental equations of the efficiency which we have started, or our analysis started in deriving the equations for the efficiency of diesel cycle, the fundamental equation is this: 1 minus 1 upon gamma into T4 minus T1 upon T3 minus T2. Put all the values 1 upon 1.4. T4 is how much? 1143 Kelvin. T1 is how much? 330 Kelvin. T3 is how much? 2223 Kelvin, and T2 876 Kelvin. Simplifying this, you will get 5689. So ideal efficiency eta is equal to 56.89%. This is your first answer. Second, This we have find out. Second, maximum pressure. So for your understanding, this is your PV and this is the maximum pressure. This is 0.1, 2, 3, 4. We are interested to find out the maximum pressure of the cycle, that is here. P2 is equal to P3, that is here. P2 is equal to P3. See how we can find out. Maximum pressure in the cycle is equal to P2 is equal to P3. As the process 1-2 is the compression, and that for that process you can write down P1 V1 raised to gamma is equal to P2 V2 raised to gamma. For this process of compression, process 1-2, you can write this P1 V1 raised to gamma is equal to P2 V2 raised to gamma. So P2 is equal to P1 into V1 upon V2 is to gamma. V1 upon V2 is nothing but the ratio R. So P2 is equal to P1 into R raised to gamma. Now T2 is equal to T1 into R raised to gamma minus 1, that we know. So R is equal to T2 upon T1 raised to 1 upon gamma minus 1. We have already with us T2 and T1. Putting this value, that is 876 upon 330 and gamma 1.4, 1 upon 1.4 minus 1. So you will get R is equal to 11.48. So P2 is equal to P1 into R raised to gamma is equal to P1 is equal to 1, R is equal to 11.48, gamma is 1.4. So you can get the pressure P2 is equal to 30.47 bar. This is the maximum pressure in the cycle. This is your answer. So you have also find out this maximum pressure. What is given in the data? 4 temperatures are given: T1, T2, T3 and T4 at all this point: T1, T2, T3 and pressure at P1 is also given, 1 bar pressure is given. Gamma we have taken it 1.4. By the fundamental equations of the efficiency, we could write 1 minus 1 upon gamma, T4 minus T1, T3 minus T2. This is the efficiency for the diesel engine. Put all the values, you will get first answer. The efficiency of the cycle of the engine is 56.89%. Next, we are interested to find out the maximum pressure in the cycle. Maximum pressure means pressure at point, either at point 2 or at point 3, that is P2 is equal to P3. So P1 in V1 is P1 V1 gamma raised to P2 V2 raised to gamma. This is applicable for the process 1 to 2. It is applicable for the process 1 to 2. From there, you can take that P2 is equal to P1 into R raised to gamma. From there, P2 is equal to P1 into R raised to gamma. Right? We had with us T2 is equal to T1 into R raised to gamma minus 1. We had with us T2 is equal to T1 into R raised to gamma minus 1. So R is equal to T2 upon T1, 1 minus gamma minus 1. Put the values, you will get the value for R. Put that value in these equations, you will get maximum pressure in the cycle 30.47 bar. Let us move to further in this exercise. It is given the compression ratio of an engine which is working on the diesel cycle is 15. Cutoff takes place at 10% of the working stroke. The temperature and the pressure at the beginning of the cycle is 100 kilopascal and 27 degree centigrade. Assume specific heat at constant pressure Cp is 1.006 kilojoule per kg Kelvin and Cv is equal to 0.717 kilojoule per kg. Calculate the temperature and the pressure at the end of the compression and efficiency of the cycle. It is that compression ratio of an engine is given 15. Cutoff is given 10% of the working stroke. The beginning condition is given pressure and temperature. You have to find out the temperature and the pressure at the end of the compression and the efficiency of the cycle. Let us see. What is given? The given is R, that is V1 upon V2 is equal to 15. Cutoff is given. Cutoff is given 10% of the working stroke. 10% of the working stroke. T1 is given 27 degree, which comes out 300 Kelvin. And pressure is given 100 kilopascal. It is also given, you take Cp is equal to 1.006 kilojoule per kg Kelvin standard for air, CV 0.717 kilojoule per kg Kelvin. From CP and CV you can easily find out the gamma. Gamma is nothing but Cp upon Cv is nothing but 1006 upon 0.717. This comes 1.403. Right? Now, we have to find out the temperature at the end, that is at point 2. You refer the figure which we have already referred in the previous problem. T2 is equal to T1 into R raised to gamma minus 1. This is 300 into 15 into 1.403 minus 1. So this comes 893.48 Kelvin. 893.48 Kelvin. This is the temperature at the end of the compression. Temperature at the end of the compressor. First answer. Then what is pressure at the end of the compression is also asked. So that is pressure at point P2. We have seen our previous problem. P2 is equal to P1 into R raised to gamma. P1 is given 100, R is also given 15, gamma we have already find out 1.403. This comes 4.467.412 kilopascal. This is P2. This is your second answer. Pressure at the end of compression. Pressure at the end of compression. Now we have to find out the efficiency of the cycle. We have to find out the efficiency of the cycle. Efficiency of the cycle is how much? What is given, that is cutoff is given. Cutoff is given 10% of the working stroke. So you can take over here RC cutoff ratio minus 1, R minus 1 is equal to cutoff is given that 10% of the working stroke. So it is 10 by 100. C. Because R is V1 upon V2, that is given. we are interested to find out the RC. We are interested to find out the RC. So RC is equal to 0.10 multiplied by R minus 1. This R minus 1 plus 1 is equal to 0.10. R minus 1, what is R? It is 15. So 15 minus 1. So 0.10 into 14 plus 1. This is 2.4. RC is 2.4 cutoff ratio. You have a standard formula of the efficiency. Eta is equal to 1 minus 1 upon R raised to gamma minus 1 into 1 upon gamma RC raised to gamma minus 1 upon RC minus 1. So putting all the values, 1 R, it is given 15, gamma minus 1, 1.4 minus 1, multiply by here gamma 1.4, RC we have find out 2.4, it is 2.4 raised to 1.4 minus 1 upon 2.4 minus 1. These calculations gives you 0.5844. So efficiency is equal to 58.44%. This is the cycle efficiency for a given data, which is diesel engine or the engine running with the diesel cycle. Once again, just repeating, here in this problem a new thing is given or the data is given in the new form, that is cut off 10% of the working stroke. So 10% of the working stroke, if you refer this figure, PV diagram 1, 2, 3, 4. V1 upon V2 is given. Cutoff is 10% of working stroke. This is given, this 2, 3. For that, it is not given directly, but it is given that cutoff is 10% of the working stroke. Whatever the working stroke is, 10%, after 10% of that cutoff takes place. So T1 is given 27,300 Kelvin, P1 is given, Cp, Cv is given, you can find out gamma. We had with this formula T2 is equal to T1 into R raised to gamma minus 1. We are interested pressure and temperature at the end of compression, pressure and temperature at the end of compression. So that is T2. With this formula we will get this pressure at the end of the compression, here P2, P1 into RS2 gamma, you will get this. For efficiency of the cycle, we have these equations where we do not have this cutoff ratio. So the cutoff ratio RC minus 1 upon R minus 1 is equal to 10 upon 100. This is given, 10% is given. So we can put in this way. So RC is equal to 0.10 R minus 1 into 1 plus 1. So 0.10 into 14 plus 1 gives RC is equal to 2.4. Put in this equation, you will get efficiency is 58.44%. So this is the problem based of the diesel cycle. We further move one more exercise. You can just see an engine operates on the air standard diesel cycle. An engine operates on air standard diesel cycle. The conditions at the beginning of the compression stroke are 80 degrees centigrade and 100 kilopascal, 100 kilopascal. While at the end of the compression stroke, the pressure is 4 megapascal. The energy absorbed is 700 kilojoule per kg of air. Calculate the compression ratio, the cutoff ratio, the work done per kg of air, and thermal efficiency. This is the problem, numerical problem based on diesel cycle. Let us see what is given and what to find out. The given data, what is given? We have given the initial temperature T1. It is given 80 degrees centigrade is equal to 353 Kelvin. Pressure is given 100 kilopascal, that is 1 bar. Also at the end of the compression is given the pressure P2, that is equal to the P3, 4 megapascal. Q supplied, the heat supplied QS is 700 kilojoule per kg of air. What we have to find out? Find out the compression ratio R, the cutoff ratio RC, the work done per kg of air, and the thermal efficiency of the cycle. This we have to find out. This is the diesel cycle. It is the constant volume cycle. First process 1-2. You refer the standard figure which we took during the explanations of this cycle. For process 1-2, it is isentropic compression. So R is equal to V1 upon V2 is equal to P2 upon P1 raised to 1 upon gamma. P2 is given 4 megapascal 40 bar, 100 kilopascal 1 bar. Gamma, you can take gamma is equal to 1.4. So you will get R is equal to 13.942. R is equal to 13.942. This is your first answer. You have got R. R is equal to 13.942. See the next. You also know that P1 into V1 upon T1 is equal to P2 into V2 upon T2. Therefore, T2 is equal to P2 V2 T1 P2 V2 T1 upon P1 into V1. Putting this value of P2 40 into 10 raised to 5, temperature 353, P1 1 into 10 raised to 5. We are converting the unit, and V1 upon V2, V1 upon V2 is, what is that? We have find out the ratio 13.942. Solving this, you will get T2 is equal to 1012.78 Kelvin, right? The heat supplied, next, heat supplied, that is equal to QS is equal to Cp T3 minus T2. Heat supplied is given 700, Cp 1.005, T3, T2 we have just find out 1012.78 gives you T3 is equal to 1709.29 Kelvin. For the process 2-3, process 2-3, which is constant pressure process. Which is constant pressure process. Cutoff ratio is equal to RC is equal to V3 upon V2. That is equal to T3 upon T2. So it is 1709.29 upon 1012.78, because T3 and T2 we both find out putting the values. You will get RC is equal to 1.688. This is your second answer. Cutoff ratio. This is your second answer. Efficiency of the cycle. Efficiency of the cycle, that is equal to 1 minus 1 upon r raised to gamma minus 1 upon gamma into RC raised to gamma minus 1 upon RC minus 1. By putting all this value, you will get efficiency is equal to 60.87%. Efficiency is equal to 60.87%. Answer. Work done of the cycle is nothing but efficiency into the heat supplied, because we have seen that efficiency is what? Work done upon heat supplied. Efficiency is work done upon heat supplied. So work done is equal to efficiency into heat supplied. This is equal to 0.6087 efficiency into heat supplied 700. So this comes 4 to 6.09 kilojoule per kg. This is your work done. This is your last required answer. Once again repeating the diesel cycle problem. Temperatures are given, T1, pressure is given, maximum pressure in the cycle P2 is equal to P3 is already given, heat supplied is given. We have to find out ratio R, cutoff ratio, RC, work done and efficiency. We have equations R is equal to V1 upon V2, P2 upon P1, 1 upon gamma. You will get the cutoff ratio, that is R. Compression ratios are P1 V1 T1, P2 V2 T2. Based on that you will get T2, heat supplied at constant pressure, that is QC, is equal to Cp T3 minus T2. So you will get T3. Put over here you will get cutoff ratio RC. Efficiency of the cycle, we have a standard formula. Put, you will get the answer. Efficiency is nothing but work done upon heat supplied. So work done is efficiency to heat supplied. You will get the answer. So friends, here we have seen the various problem based on the diesel cycle. We have also done the exercise based on the Otto cycle and the exercise based on the Rankine cycle. So we have seen in nutshell the whole heat engine. I request all of you to go to the good book, refer the theory and do more and more numerical problems based on that theory, which is very simple. Understanding of the fundamentals will help you to solve the problems in a variety. A very best wishes and wishing you a very, very happy time ahead for your learning. Your learning should be pleasurable. So best wishes from all of us here. Thank you.